Thank you for clicking on the help video. So in this example, we have a piece of equipment values at $1,700 and it's going to depreciate, which means it's going to decrease to half of its value every 9 years. So how are we going to figure out the value? Okay, well, because it's going to become half, that means that in 9 years, the amount that we have in 9 years is going to be half that value there, which is half of that. That's going to be $850. So K is calculated by getting the natural log of this amount in 9 years and dividing it by the initial amount. And then that number gets divided by the time, which is going to be 9 years. So 850 divided by 1700 divided by 9. Now, what I want you to pick up on this is these shortcuts right here, because we're going to depreciate this to half. It's like half-life. So we know that the ratio of this over this is going to become half. So all I need to do is take the natural log of 1/2. So it tells me exactly what value I'm going to take the natural log of. And that number there, the natural log of 1/2, which is going to be the same number every single time, in this situation will be divided by 9. So let's see what that is by plugging into Desmos. So I'm going to start by storing this answer into the letter K. So I'm going to have K equals to divide the natural log, again, of the 850, like I mentioned, divided by the 1700. And that's going to be divided again by the time, which I said is 8 years. Now I want you to pay attention again to this value. Let me get rid of this. And look what happens here. So here, because it's half-life, notice that this value of half, okay, is equal to the same number. So K, that's going to equal to the same number as if I take the natural log of, again, the 850 divided by the 1700. Okay, see, it's the same. So you have a little shortcut there on what we're going to take the natural log of when it's half-life. Sorry, this number is supposed to be 9, okay? So we need to round this answer, which again I stored as K, to 3 decimal places. So our answer for K is negative 0.077. So with K equaling to negative 0.077, I said that wrong last on the other slide. We get that the amount, we can now use that amount to figure out the exponential decay model for this asset's value. So the amount in terms of T will start off with the 1700 e to this K value of 0.077 times T. And we can now use this answer here to evaluate part C, which is estimate the value of this equipment after 18 years. So we're going to evaluate A when T is 18. So let's plug this into Desmos and see what we get. Okay, so let's type this in. And I made an error and I need to go back and fix it on the example. I meant to write 1700, not 700. That's going to be raised to the negative 0.077. And our time, again, we're going to evaluate this in 18. So we end up with a total of 425. I'm going to store this value to the letter A, so that way I can round the letter A to 0 decimal places, and we end up with 425. So here's our answer for the first and second part. I'm sorry, for part B, and both of these numbers are acceptable. So here's our answer for part A. I forgot to highlight that one. For part B, and I need to fix this here. This should have been 1700, which is what I wrote on Desmos. So now let's move on to part D. So in part D, we want to solve an equation because instead of evaluating, we're going to use this model now to determine the time when the value is going to reach 169. So we're going to get this model. We don't know the time. We're not going to plug a number for T, but we want this amount to go down to 169. So we know that for some amount for t, our value has to be this. So all we're doing is basically solving again this equation, replacing this with that number. And even though it looks kind of weird, it's backwards because I just wrote this on the other order. So I just have this equal to a of t, because that's how I like to see my equations. So I'm going to divide this by the 1700. And then e to the negative 0.077t equals to the ratio of 169 over 1700. We're going to now take the natural log of both sides. So this can cancel out, and we're left with negative 0.077t, and that equals to the natural log of this ratio. We divide one more time, let me not forget that negative sign. And there is our answer. So t equals the natural log of 169 over 1700 divided by negative 0.077. And this again is the format for every single thing. Notice that this format here looks exactly like the value of k, because that's all we're doing. We're just simply switching the values of k and t, and of course starting off with it and ending with a different value. So we need one value specifically to get the value of k, and then using that, we can then use a different a of t to find again the time to get to that value. So look, this number comes from this value in the equation. This number comes from the initial amount, and this comes again from the k. So it's the same format as before. So let's just plug it into decimals and see what we get. All right, so in decimals, we're going to start by first clicking divide, natural log in the numerator, our parentheses, and we're going to get again this 169 and divide that by the 1700. We're going to move that cursor down so it could be below again that value, and that number will be divided by our k value, which is negative 0.077. Now I'm going to store this answer, this number as t. So I'm going to say t equals to this number. That way here I can round the value of t without having to copy and paste again to 0 decimal places. So our answer is 30. So our number is 29.98, which again estimated to 30. So both of these are acceptable as your decimal values. You have to again use decimal values for these questions here. Now I hope this video was helpful, but if you still are confused or stuck on anything on your specific example, send me a message to email or message my instructor. Thank you for watching, and I hope you have a good day.